Hello, in this video we're going to work on checkpoint 5.11. They want us to evaluate the double integral of x squared plus y squared dA over the region D in the first quadrant between the functions y is equal to 2x and y is equal to x squared. Then evaluate the iterated integral, integrating first with respect to y and then with respect to x. Alright, let's figure out how this graph is going to look like first. It's y is equal to 2x is a line, slope 2, and you got your standard parabola. And the other important part that's needed here is where they intersect. So we need to figure out those points where they intersect. So clearly this is going to be 0. And if you set these two equal to each other and factor out an x is equal to 0 and x minus 2 equals 0. So we get x is equal to 2. And if we need to, the y value of that is going to be 4. When you put 2 in for either of those two functions, you're going to get 4. Okay, type 1 region. This is going to be a type 1 region. And type 1, we don't need to memorize the types. I guess it would be good if we did, but it's more important to figure out how these limits of integration comes about. We want to integrate with respect to y first, and so we will set up some y inequalities, and then x would be constants. The limits for this would be constants. Okay, with the y, I would draw a line parallel to the y-axis through the region, and you would ask yourself where you would enter the region and where you would exit the region. And it looks like here I would be entering the region via this lower function, and it would be a y limit. So I would say y is equal to x squared is your lower limit, and then you'll be inside of the region until you get out that this y is equal to 2x upper limit. Alright, and again the outer limits would be constants, so that just goes from 0 to 2. And now that we have this, we can set up our double integral. Our double integral from of x squared plus y squared dA, and this will have over d, then this will become an iterated integral, and we have x squared plus y squared, and then we're going to choose to integrate with respect to y first, and the y limits are going to go from x squared to 2x. Now I notice that the book does this a lot when they put y equals. I think that's good practice, just so you know what you're integrating or what these values are that you're integrating with respect to, but it's not necessary. So it's up to you. And then our x values are going to go from 0 to 2. Okay, now it's just a matter of working this out. We integrate with respect to y. X squared is constant, and then we have y cubed over 3. So the inner integral here will produce x squared y plus 1/3 y cubed. We're going to integrate that from x squared to 2x. So let's put 2x in for y. Again, putting that y equal there would make things a little bit clearer. This would be x squared times x squared, so that's going to be, or let's put 2x in first. So it'll be 2x cubed plus, and then this is 1/3, and then we'll put a 2x in there, so it'll be 8x cubed. And then let's put x squared in there, so this would be x to the 4th, and x 1/3 and then this is going to be x squared to the third power, so we multiply the power x to the sixth. Okay, so now let's put that in. I don't know if there's any simplifying that could happen here. Let's see. Possibly this first two. We got 8/3 plus 6/3. That's 14/3. 14/3 x cubed minus x to the fourth minus 1/3 x to the sixth. Okay, let's now put this into this integral. Let's go over here, and now we have the integral for x values from 0 to 2 of this whole thing that we just got. That's 14/3 x cubed minus x to the fourth minus 1/3 x to the sixth dx. And we'll go and integrate that. We're going to get 14/3 times x to the fourth over 4 minus 1/5 x to the fifth, and this is going to be minus 1/3 x to the seventh over 7, and we need to evaluate this from 0 to 2. Okay, well, I'm just gonna, so this is just some tedious work that we need to, arithmetic work that we need to just plug in. So let me just tell you what I eventually got. I eventually got 216 over 35 after a little bit of simplifying. Okay, all right, so this is your integral. I hope that helps.